Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
The idea is this, that if you have two polynomials, let's say Pn and Qn, okay? Let's say Pn is equal to nq plus 3nq plus 2n square plus 1 and Qn is equal to 4nq plus 3, okay? So now understand how will limit n tends to infinity Pn by Qn work. So observe also Pn by Qn, Pn is going, it's Pn is, so let's say even if Pn is greater, so observe that for n greater than 0, Pn is greater than Qn because n is 0 greater than 0, so let's call it this. N greater than 1, Pn is greater than Qn. But still, this will not go to infinity. The reason is this. The reason is this, that as n goes to infinity, this surpasses, the behavior of this surpasses the highest degree, surpasses the other degrees. So therefore, limit n tends to infinity, it will be nothing but the highest degree by the lowest, the corresponding highest degree is 5 by 4. So the general result is this is equal to, so there are two cases. Degree of Pn is less than degree of Qn. Degree means, I hope you understand, if you remember the polynomial, what is a polynomial, I expect you should know that. The other two cases are equal to, another two cases are greater. If degree is Pn, that means Pn is behaving like in the long term, it's like n square, and the bottom it's like n cube. It's like, therefore it will become n square by n cube, and it will go to 0. You can understand this. A 0, yeah, it will go to 0. Yes, right. Even if it's minus, it will go to 0. From the negative and right side, it will go to 0, but it will go to 0. For equal to, so if the degrees are equal, then it will go to the the two coefficient ratio. Okay, so coefficient of highest degree of Pn by coefficient of highest degree of Qn. And if degrees of Pn is greater than Qn, then that's the thing. So it can be either of the form n cube by n minus or n cube by n plus. So either it will go to plus infinity or minus infinity accordingly as the coefficient. If this coefficient, so let's call this coefficient alpha pq. So it will be alpha pq in this case. In this case, if alpha pq is less than 0, this will go to minus infinity. If alpha pq is greater than 0, it will go to infinity. So it will be like n cube n square or minus 2n square. Like this will go to minus infinity, right? And this will go to infinity. So, and alpha pq is greater than 0, alpha pq is less than 0. So these are certain known things you need to know. Okay. Another interesting thing is that limit e to the power n by any polynomial will always go to infinity. Okay, any limit, because e to the power n is like a super exponential stuff. Okay, that's why the polynomial, even if it increases, it will never go to infinity. Never be. It will always be surpassing that. Yeah, it goes to infinity if the polynomial highest degree is positive. It depends upon the positivity. Like if it's, let's say it's n, it will go to infinity. If it's minus n, it will go to minus infinity. If it's less than 0, it's minus infinity. So you have to understand this. This is a very important small minor things. Okay. Also, another interesting idea is that for a limit n tends to infinity n by any log n by certain n to the power of k till k, if k is greater than 1, it always goes to 0. You can easily prove it by L'Hopital, okay, if you know L'Hopital. Otherwise you can just assume it. Like the basic idea is that log n is like this and n is like this, so it's like n square or n to the power k is like this, so it will like surpass log n. Okay, but anyway, anytime log n is like this, I'm sorry. So there are certain results you need to know, certain ideas you need to know before approaching the problems. Okay, now let me solve this problem in a mathematical way. This is how you should think in examination, but how do you think in a mathematical way? So what did we get? That limit n tends to infinity, this goes to what? Limit n tends to infinity e to the power 2n, right? This is what we got, right? So what we can write is that this is equivalent to writing that limit n tends to infinity will go to 1. This is equivalent to writing this limit n tends to infinity by 2 to the power n will go to 1. And that's why this is equivalent to C, what it's written here. Now this idea that both are going to the same limit, this is a basic idea that gives the basic fact that the order idea. It comes to the order idea, and I will do that after this. But did all of you understand the basic idea of algebra of limits and its some examples and how to apply it? I will do another way of doing it, that is called the Taylor series expansion. And that's why you should know this Taylor series expansion when you do the. That's why I am telling you, for doing problems where you have dysfunctional format, you need to know differential calculus well. And we'll come back to this later on. But the basic idea is that this you can expand this as summation of some, for example, if you expand this, it's a plus b whole to the power something k. So you can expand this as 1 to the power n square, right? Plus n square, choose 1, like the binomial theorem, 1 to the power n square minus 1 times 1 by n whole to the power 1 plus n square, choose 2, 1 to the power, like you can see the 1 coming up there naturally, okay, and there 1 by n will come up, accordingly, n square plus e to the power 2n. You can actually find it will be nothing but 2n, it's x by n factorial, x to the power n by n factorial, so it's x 2n by 1 plus 4n square by 2 factorial. Okay, this is there is an expansion. This is something you will learn in differential calculus, but if you have no mathematics, you probably know this, or probably not, but there is some results like this. It's to the 8n cube, and it'll go ahead, okay, and from here you will get to understand like where it needs to stop. Okay, for this it's of the form n square here, it's of the form n here, so essentially it's n, the degree is n. Here is the form n square, choose 2, so it's n square into n square minus 1 by some constant. You have to find the constant into 1 by n square, so it's n square. Here n square into the cube, the next one, so n square into n square minus 1, n square minus 2, so n to the power 6. The next one will be probably n cube, so it's n cube. So essentially it's the same degree. Okay, so how do you stop? When do you stop? That's one interesting idea. Okay, so we'll learn this idea later on, but yeah, so think about this problem, how you can connect this to polynomial thing. Or did I do this correction or right or not? Just check this. Okay, did I do this correction right or not? If we cannot do this by this, then what other methods are there? So essentially, the basic first takedown is that, like first takeaway is that the differential calculus knowledge will leave more impact on finding limits of functional forms. Okay, that will help you more understanding it better. Or others use algebra of limits, but there is also one method left. There's also one method left, and what is that method? Okay, so the basic idea is this. So understand what were we doing in the algebra of limits. The algebra of limits nothing but there are some known set of limits. By some method out there, we're finding the algebra, we're finding the equality of limits. But there is also another method too. It was all about equality. Okay, but there are other methods. So there is the method of inequality. Here it was all equality. If this is equal to this and this plus this is equal to this, but there's also a method of inequality. Okay, and that's called the algebra of inequalities, like on limits, order properties on limits. And this is very powerful because you're using limit inequality should show the limit. Okay, and this is very interesting. You're using inequality to show limits. So essentially, what we are doing, we are comparing the known limits, and this is very interesting. This is how our mind works. We have a known set of knowledge, we're using that and comparing that to find more limits, comparing known limits to find new limits. And this is the connect, and the comparison can happen by algebra of limits, the equality case or the inequality case.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.